Start now. Okay. So, can everyone see the screen?
Yes, ma'am.
Yes, ma'am.
One more minute while I plug in my earphones. But otherwise, everyone else will get disturbed. I need a list of all the people who are involved. Okay, and holiday list I need to business right now. Fourth year, second year, interns, PGs, everyone. List, that's all. Okay. Am I audible to everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Just at 10 o'clock, I'm going to lecture. Okay? Yeah. So we are going to look at SWD. The first thing that we're going to start with is we're going to let's see the. We're going to revise the first year portion that we've done. A quick revision, not in depth. A quick revision. Then we're going to start listing the methods of how SWD produces heat. Okay. Then we're going to discuss these methods a bit more in detail. Okay. Fine. And
Yes,
then we're going
ma'am.
to move
Yes.
in contraindications, listing merits, demerits, advantages, disadvantages, in other words. And then we're going to look at the placement of the pad electrodes. Okay, and the reasoning behind specific placements. Everyone okay with this?
Yes, ma'am.
Yes,
Yes, ma'am.
Yes, right? What I'm expecting at the end is you should be able to discuss SWD in detail right from the production. So the first year part, so right from the production down to the placement of electrodes for the different conditions for which we can use SWD. Okay? Fine?
Yes, ma'am.
Yes, ma'am.
Yes. If you have got questions anywhere, you will stop me at that point and clarify your doubt. No doubt is stupid. No doubt is dumb. A doubt is a valid question that you will always have, and it is better to clear them before we move ahead. Okay? If I have the information at hand, give that information. If I don't have it, I will find that information and I'll send it across. Okay? Fine. So please do not think that how can I ask such a question? Just ask. Right? Okay. So we are going to first start with the revision. You all know it's a deep heating modality, right?
Yes, ma'am.
Why do we call it a deep heating modality? Why do we call it a deep heating modality? Any idea?
High frequency therapeutic device.
Being used. Okay, so the penetration of a high frequency current is deeper as compared to a low frequency current. Okay, good. That is one reason. So you're looking at the penetration depth of that current. Yes? Everyone remembers this? Frequency is inversely no, it is directly proportional to the depth of the penetration. So the higher the frequency, the more is the penetration. Everyone remembers this?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So I'm so sorry for that. So I'll just switch the focus mode on. I don't want any. Yes. Sorry for that. So we are looking at a high frequency current which is penetrating quite deep into the tissues. Can anyone remember to what depth it goes? Or can anyone guess to what depth it goes? Why are we looking at this? Because when you have to compare and contrast between the various heating modalities, you should know why you're using a particular heating modality. We've got so many options. No? We've got hydrocollator, we've got PWP, we've got IR, we've got ultrasound, we've got SWD. All are heating modalities. So why are we preferring one modality over the other? So the answer lies in this part, right? So when we think of SWD, we are looking at a penetration of almost up to the bone, right? So looking at the whole of the muscle being treated, whatever is the depth or whatever is the thickness of the muscle. So you can even treat a, a muscle like the quadriceps with SWD. Okay, okay with this?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
When we start looking at the various conditions which we can treat with SWD, you have to look at the structures which are going to get affected or structures which are going to get affected when you start using SWD. So this is a deep heating modality, basically because it is a very high frequency current. Can someone tell me the frequency?
27.12 megahertz.
Very good. So it is 27.12 megahertz. Okay. So because of this very high frequency, it is going to penetrate quite a lot into the tissues, and therefore we are calling it as a deep heating modality. Okay. Everyone
Yes,
okay with this?
Yes,
Right.
ma'am.
So,
yes, ma'am.
okay. So this uses electromagnetic induction to produce the effect. Okay. Can someone describe the electromagnetic induction that is taking place?
Electric current flowing through one coil induces a magnetic field around the other coil.
This is the opposite coil. Okay. Correct. We are looking at the current over here first, then we'll be looking at the magnetic part. Okay. Right. So, do you remember we have a very high frequency current, 27.12 megahertz. Do you remember how we get this 27.12 megahertz? Which is the component, which are the components which are responsible for this high frequency? Can we produce this frequency?
The resistance, the triode valve,
Very good.
due to which the
And
direction
the
of the
capacitance and the transformer.
So the triad valve, which transformers?
Step up and the step down transformer.
Actually, we are looking at the even ratio transformer over here.
It's the oscillator circuit, ma'am.
Yes, in the oscillator circuit. But in the oscillator circuit, we have got three transformers, the step up, step down, okay, which are going to produce the initial current which is required for SWD. And then we have the even ratio transformer. You remember after the triode valve? So from the positive of the triode valve, we get the even ratio transformer. One segment of which, one coil of which is reflected. साफ करायचं आहे? One segment of which is reflected on the grid circuit, triode leak on the grid leak circuit, and the second which is to the patient circuit. Do you have diagram up in front, or do you remember the diagram?
yes, ma'am.
Yes, ma'am.
Yes, ma'am.
When you have a transformer like that, we are looking at the even ratio transformer, which is going to move, which is going to get connected to what? The machine capacitor, the static capacitor, right? And every time current flows through this circuit, it is going to charge the capacitor. And when the triode valve's grid becomes negative and electron flow stops in the triode valve, the capacitor is going to discharge and send current in the opposite direction. Remember this? So there was
Yes,
Yes, ma'am.
charging and discharging of the capacitor, right? So that is the cycling that you are going to see, which is the 27.12 megahertz. Okay? Understood? So that is what about the 27.12 megahertz frequency that you are talking about when we think of the parameters of SWD. Correct? So you have got two circuits in this now. We have just described the machine circuit. Is everyone remembering the machine circuit now?
Yes, ma'am.
Yes.
Yes, ma'am.
Right. So when we are looking at the machine circuit, we have got three coils in close proximity to each other. Okay. Machine circuit is giving an opposing current in the grid lead circuits transformer coil, and the other coil is the patient circuits coil, which is getting a current induced in the same direction as the machine circuit. Correct? They are facing in the same direction. Okay? Are you
Yes.
remembering this part? Or do you want me? Yes, ma'am. Because it is difficult for me on the phone. Do you remember this part?
Yes,
Yes.
ma'am.
Right? So when we look at the patient circuit now, we have got the coil of the patient circuit and thus variable capacitor of the patient circuit. Correct? We have a variable capacitor, correct? Or do we have a static
Yes.
capacitor here?
Variable capacitor in patient circuit.
Okay. Just give me 1 second. Mama, aaj jao. Right. So, why do we have this variable capacitor? Does anyone remember?
To maintain the frequency of machine and patient circuit.
Very
Resonance.
good. What's that?
Non-patient.
Sorry?
Yogita, ma'am.
Okay.
Yogita.
So you want to maintain the frequencies or you want to equalize the frequencies of the patient circuit and the machine circuit. Therefore, you have the variable capacitor, right? Now we are going to go into the depths of why we require the variable capacitor. Okay. Now, when you tested the machine, let's go into the testing part so that we will be able to understand why we are using the variable capacitor. Okay, this was a part which we did not cover in the first year because it was not applicable at that point of time, but now it becomes applicable. So we had three different methods of testing the SWD apparatus. So one was where you saw the lights all glow when the machine started and the timer was set to whatever the duration, correct? That was one way. Then you saw the ammeter deflection, right? So you knew that the current was flowing in that circuit. Then you tested with the neon tube, and then you tested with your hand across the pad electrodes. Do you remember that?
Yes.
Yes,
Yes.
ma'am.
Of these three methods, where did you have to tune the most?
Neon tube.
Non-tube.
Tuning जास्ती लागलं. Where did you have to tune? You use the tuner knob, right, to get it to the maximum deflection.
Yes, ma'am.
So where did you have to tune the most? Where did the knob turn the most?
When we placed our hand on the pad electrodes.
Now that is basically wrong question. The why part will be after I finish talking about all these things. So that is what we're going to look at now. Why are we looking at the tuner knob, or why do we have variable capacitor behind the tuner knob, especially after we place our hand across the two pad electrodes? Okay. So if you remember, I think I had showed you. I think for your batch, I had showed you that animated part where you could see those blinking lights for the SWC. Yes? No? I had showed you a PPT, right, for SWD last year.
No, ma'am.
Yes or no? Do you remember or no?
No, ma'am.
No, ma'am. We had a
No, ma'am.
lecture.
I had showed it on the blackboard. Okay, in that case,
Yes, ma'am.
in that case, for tomorrow's lecture, I will just run through that PPT so that you will understand exactly what I'm talking about. Now, when we are looking at the patient circuit, the variable capacitor is actually the one which is going to help us to tune both the circuits, to resonate both the circuits. Why is this resonance necessary? Because SWD, the machine, has to work at its maximum efficiency, and therefore we need to ensure that both the patient circuit and the machine circuit's frequencies are matching each other. Okay. Now, what happens when we place our hand across the two pad electrodes? Did you notice that the deflection dropped drastically?
Yes, ma'am.
Yes, ma'am.
Tune. Now, why was this happening? Because our tissues, okay, our tissues hold a water, ions, molecules, proteins, various components there in
Your
tissue.
voice is breaking a lot.
Is this better? I'm in full range. Yes. Is this better?
Yeah, ma'am.
Yes,
Yes,
ma'am.
Yes.
From where should I repeat?
resonance, ma'am.
Okay, resonance. So when you placed your hand across the pad electrodes, your ammeter deflection dropped drastically. There was a major deflection, right? The needle dropped very much, right? So why did that drop? Because we were introducing patient tissues, or rather the therapist tissues over here. We were introducing tissues, human tissue, in that force field, in that electromagnetic field. Correct? You're going to get electromagnetic, sorry, you're going to get electromagnetic induction between the two pad electrodes. So your lines of forces are from one pad electrode to the other. And when you're introducing the human tissue in that force field, in that electromagnetic field, there is going to be an effect on the field, right? So when that happens and your the inductance capacitance product does not match that of the machine's inductance capacitance product, you will need to use the variable capacitor to increase or decrease the capacitance required. Okay. Therefore, we are using the variable capacitor. Now, why do these tissues produce that much of a deflection or that much of a drastic drop? That is because the tissues are composed of multiple elements. You get water, you get proteins, you get molecules in the sense, molecules which don't have charge, molecules which have a charge. Okay, you've got cells. Those cells might or might not have a charge. Okay, so the charge can vary. Whatever variance occurs is going to get added over there. The charge that is being that is there of these tissues is going to get added to that capacitance, right? Correct? Are you with me till now?
Yes, ma'am.
Yes, ma'am.
You have an extra capacitance, you will need to ensure that both those capacitance are included in the product component. So when we look at LPCP, when we are looking at the capacitance part of the patient circuit, we are looking at two capacitances. One which is produced by the variable capacitor, and the second which is the skin tissue, which is the human tissue, not the skin, the human tissue. Correct? Understanding this?
Yes, ma'am.
Yes, ma'am.
Understanding why human tissue has got a particular charge. Yes, no?
Yes, ma'am.
Is everyone understanding why human tissue has got a charge?
Can you repeat it, ma'am?
Okay. Human tissue is composed of which materials? You've got matrix, then you've got cells, correct? Then you've got free flowing ions, you've got free radicals basically. So they are ions. So they might have a positive or a negative charge, correct? Then you've got different molecules which are spread out in the extracellular matrix or the extracellular fluid, right? Correct? Proteins, you've got
Yes,
fat,
ma'am.
correct? So each of these components has got a particular charge. When you look at the nerve, is it positive or negative on the outside? Positive, right?
Positive.
Outside negative.
Positive on the outside, negative on the inside, correct? So that
Yes,
has a
ma'am.
charge, correct?
Yes.
It's a
Yes, ma'am.
charged membrane. When you look at the cell, even the cell has a charge,
Yes.
correct? So all these components have a particular charge. They are either negative or they are positive.
Yes, ma'am.
Understanding this, right? So when you have a charged particle that can act as a capacitor. So if I'm
Yes.
introducing a current in that situation, what will happen to all these charged particles? They are going to get repelled same from the same charge, and they are going to get attracted to the opposite charge. Understanding this?
Yes.
Right? So essentially, this is producing a capacitor-like effect.
Yes, ma'am. Yes.
Everyone is getting this?
Yes, ma'am.
Yes,
Right? So when you are looking at the capacitance which is there in the patient circuit, right? You have the skin tissue which has a particular capacitance. Okay. So some positive charges, some negative charges. Correct? Right?
Yes, ma'am.
So
Yes, ma'am.
when you have to equalize, when you have to ensure that the machines and the patient's frequencies are matching, and you're looking at the product of the inductance and capacitance, what happens? You cannot change the tissue's capacitance. It is going to remain constant. Correct?
Yes.
Right? You cannot change the inductance because this inductance is based on the machine's inductance. It is the same inductance as the machine's inductance. Correct?
Yes, ma'am.
Yes,
What
ma'am.
can you change now? We have three components in the patient circuit. We have the inductance, we have the variable capacitance, and we have the skin capacitance or the tissue capacitance. Okay? Correct?
Yes.
Of these three components, the inductance and the tissue capacitance are constants. You cannot
Yes.
modify those. What can you modify now?
Machine's capacity.
Variable
Machine's capacity.
capacitance.
Yes, ma'am.
Right?
Yes.
Understand the need for the variable capacitor over here? Understood the need?
Yes, ma'am.
I have to ensure that LMCM is equal to LPCP. You remember that, right? Frequency is 1 upon 2 root LP, LC. Correct?
Yes, ma'am.
Frequency is equal to 1 upon 2 root LC. Inductance into capacitance. Correct? So essentially, we are looking at the product of inductance capacitance and it should match each other.